if we read this first warm-up, we've got somebody who's going to be depositing some money into a bank, and there is an interest rate. Do you think that that is something that is going to happen in your life? Yes, it should, hopefully. Um, hopefully. But I'll tell you, there was a guy that he was my Bible school teacher, and he told us how to become a millionaire by the age of like 40 or 50, I want to say. And it wasn't that ridiculous. It was like investing $100 a month into a normal bank account, because what happens is it's not really the interest, and it's not really the money until it starts, you get to a large lump sum. Then once you start getting a large lump sum, you ever heard money makes money? That's because a lot of money will start to compound that, and start really, that interest will add up. Now you're talking about, you just put your money in and you get $5,000 just because you got your money in there. Now you're talking a significant amount of interest. Basically, your money's getting money for you. That's why I always thought it was weird that people who win the lottery, people who are like the football players. Have you seen the specials on those guys? What happens to a ton of those people? There's all of it. They're bankrupt within like 10 years. What I didn't understand is if you just took like a couple million and you just put it into a regular crappy old bank, your interest, you could live off that a year and make, Michael, hey, just take this. I think it doesn't happen. You sure? Okay. But even if you just invested that money, you could live with not having to work really the rest of your life and just live a comfortable life. But what do these people want to do? Instead of living a comfortable life, they want to buy all these cars, they want to buy all these houses. Well, the only problem with buying a couple $1 million house is what eventually happens to that roof. You have to replace it. Well, what happens when you have a gigantic roof? How much is your roof cost now? And they can't afford it. Seriously, that's the stuff that happens. When you have a big house, it's just so hard to keep clean. When they're making all that money, it's, oh man, well, I got that money. It's chump change. I'll hire a maid. All of a sudden, you're not making that million anymore. Now you've got to clean that house yourself. Now it doesn't look so easy. You get what I'm saying there? Like, it's not, it's got to be that steady income that you got to. And if they were just smart, they could invest and live a life that's unbelievable, but they would be able to sustain that life. That's just part of this culture that we live in, where people just don't think about living within their means and with being smart. I mean, we are so lucky with banks nowadays. Crazy lucky. Be careful. Mm-hmm. They do. Did you look at your credit card? Okay. With that kind of stuff, like, and I'll fill you guys in a little bit. I'm going through some financial crap with mine. I tried to help someone out. It's a long story, but my mom, all people have always told you be afraid of credit cards. And the reason that is because kids get really irresponsible for it. They charge it up. They don't pay it off. They just, because you don't have to. You can pay a minimum balance of $100. Well, that minimum balance is basically, again, like we talked about, your interest only. I told you that's basically what you're doing. And so you're just prolonging, paying someone what you borrowed back. You're just giving them money for using that money. But if you're smart, like my wife and I, always use a credit card for everything that we do, unless it's like cash only. But if we can't, we put it on a card. If I could put my house payment on a card, I'd do it. If I could put anything that I can, biggest things I can, I put on a credit card, because I don't buy anything unless I have the cash for it. I use my credit card like it's cash. And then last year, my wife and I were able to go to Alaska for our 10-year anniversary. Do you know how much that cost us for the cruise? $0. Because we took our points that we had used together for the 10 years of just buying stuff we would normally buy anyways. I go to the grocery store, I'm going to buy $100 worth of groceries every week. But instead of buying that with cash or a check, we would put it on the credit card. For 10 years, we saved those points up, and we used those points to pay for an Alaskan cruise. We paid nothing to go on an Alaskan cruise. All we did is we just used somebody else's money for a month and paid it off. Never paid any interest. But I used my credit card like it was cash. I didn't use it as, oh crap, I don't have enough money for this, so I'll just put it on my card and I'll pay it off later. I never used my credit card like that. I always made sure I had cash to back, and I always paid off my balance every single month. That's part of a rewards program. And actually I just went out and I've been looking at all the different cards. You have some cards that give you what's called cash back, but they're rewards, because what they want you to do is, most people are not responsible enough with a credit card. Most people forget how much they've spent, or they don't keep track of it. So what they do is they get you with the rewards. Do they really care about the rewards? No. That is chump change for what they're going to get you for, because they're cash back to you. So here's the problem with banks even and credit cards. When you borrow their money, like that credit card, if you looked at your interest rate, it's probably around 15 to maybe even 25%. I mean, some of them are crazy. Which means when you borrow their money, that's how much extra they charge. You know how much they give me when I use their credit card? They give me 1 to 3%. Do you see the gap? For every responsible person, right? This person pays for 5 of me. This one person who's not responsible with their credit card pays for 5 of me. So they take their chances, and they think there's going to be more people who are not responsible with their credit cards. They're going to, at some point, get interest. And on top of interest, if you don't pay, most of the time if people don't pay, they don't pay on time either. So they hit you with a late fee. This doesn't include the late fees or anything. This is just when you have money left over. Let's say you spent $5,000. Okay? They charge you, if you don't pay anything, they charge you 15% on that $5,000 each month, and a late fee if you didn't pay. Let's say you paid the $100 and whatever dollars, the minimum amount. They won't charge you a late fee, but whatever's left over, let's say you give them $100, they're still going to charge you 15% on this $4,900. What, this reward? Oh, they'll give you the rewards. Oh yeah, and if you don't, then they're just going to trash your credit. Oh yeah, no, you still have to pay that back. Do you guys kind of get what I'm talking about? The other thing that I do to try to help myself out, I know we're talking a lot of finances, is I put money away. So with banks, when people used to go to the bank, or they wanted to put something in their savings account or anything like that, what did they have to do? They physically had to go to the bank. They had to sit there and they had to wait in line. Now when you want to change something around, what can you use? Use an app. You don't even have to, before you had to go and cash a check. Now half the banks you can use your cell phone, snap a picture of it. You don't even have to go to the bank to deposit. It's so ridiculously easy with how you can do your finances, and I'll share some of the things that I have. I believe so. I think they just say above 800. Oh yeah, 800 is, anything above 800 you have impeccable credit. So like what I do is with mine, remember how I was telling you about that savings, how if you just saved $100 a month, you could become a millionaire. I need to look that up. I'll look up what it was. But it's so easy nowadays. You can have an automatic withdrawal that you wouldn't even see that money. So like my wife and I have two checking accounts. One of my checking accounts is where both of our money goes into, and that's where we use our daily money. That's the money that I need to keep track of. One is for a rental property, and I have to have it. It's called escrow, so I have that just in there. The other things I have, I believe, 4 savings accounts. And each month, actually every 2 weeks, money is taken out of my checking account going into those. One of those is called insurance. You guys have to pay insurance. I pay mine every 6 months because if you pay it like that, you get a discount. I like to save. Anytime I can, I try to save money. If it's $50 here, hey, $50 over 10 years is a lot of money. To me, that's worth it. Just because I pay you up front, I'm going to have insurance anyways. You with me? So we pay ours every 6 months. Do you think I wait until June and go, oh my gosh, I have a $700 bill that I have to pay this month? Oh man, I'm really not going to be able to do my fun stuff this month. That's how some of my friends do. Because I'll tell you, they'll be like, hey, can you go play golf? Can't go play golf. Why? I got this bill due this month. Money's tight. That doesn't make sense to me. Do you know, especially like I said with banking, how easy it is? What do you think we do? Every 2 weeks, what do you think comes out of my paycheck? My money for my car insurance. Now, do I pay that? Nope. That's me saving it so that when the month comes that I'm supposed to pay my insurance, I have that cash ready. It's already been there waiting for it. Do you follow me? So I calculate how much my insurance is. Let's say it's $700 every 6 months. So I take that and I divide it by 6, right? And then I divide that by 2 so I know how much comes out because I get every 2 weeks I get money, right? So that's how much should come out of each of my paychecks. This much money goes to my insurance, and it automatically, my bank does it automatically for me. So it's not even something I physically have to do. Like my mom had to keep a checkbook and had to balance all this stuff, and it was a lot harder with finances. Now you just do that one time, you set it to a recurring thing, and every 2 weeks, money comes out of my bank and goes into my savings for my insurance. I do that with emergency fund. My emergency fund, I have about $3,000 that is, and I keep building on it. That is just sitting there. It's only there for if something ever happened. I'm a little lucky because my job is a little more like I know I'm going to have my job. It's pretty stable when it comes for teaching. But there are some jobs that are not very stable, and they say that you should have at least 3 to 6 months to where you could pay your completely bill, like all of your bills, saved up in emergency fund because there are things that happen. Cancer is becoming something like my dad just had to go through stage 4 cancer. That's something that's coming more and more. We're seeing that it affects people because when you have that, you have to go take days off, you have to go into treatments and all that kind of stuff. So you start losing money. If you have that emergency fund, you're prepared for things like that. So I take out every 2 weeks and I put into my emergency fund. I have a vacation fund that I take out every 2 weeks and I put money away so that my family and I can go on vacations throughout the year. And the last one we have is my fund for our house. We're doing renovations. We just recently refinanced. I have 2 houses. We refinanced, which means the bank paid me some money. We'll explain that when we get to housing. And so I put that in a separate fund, so I know how much money I have allocated to doing my own house, so that I don't get going too much. Because remember, I put everything on what? Credit card to make sure I don't put too much. Every time I make a big, like I just bought an $8,000 kitchen. I took $8,000 from that fund and put it right into my other fund, so I'm ready to pay my credit card. It's so easy to do finances, especially with these kind of online tools, but you do have to be smart about it. You have to be proactive with this kind of stuff. Does that make sense? Now we're going to get to actually do this kind of stuff. All right, so Javier deposits $750 into a bank account that earns interest at a rate of 3% of his initial deposit. That is huge. What only is getting interest every year? His initial deposit. What is not getting any interest? So when he goes, so after the first year, is he going to have $750 in his bank account? No, he's going to have what? More. But will that more make money by being in that bank account? No, because what's he only going to get interest on? It's $750. What that is called, there's something called compound interest, where your interest gets money on top of it. So like, you invest in this, you get 3% back, your now 3% that you just earned can also make another 3% the next year. And that interest can then the next year make, so your interest is actually growing on itself. Does that make sense? With the way this is worded, his interest will only be on that $750. So let's say he leaves this in there forever. He gets $1,000. Will he be getting 3% of $1,000? No, he will still only get 3% of his $750. Does that make sense? That's the difference. This right up here, this right here, is that compound interest formula. We will not be using that for this one. How will we be doing this problem? How much does he get? How much is he going to have in the bank account no matter what? What's that called? Constant. That's going to be there. Now, what are we going to add to that? 3% of 750, but that's going to happen how many times? So we're going to do 750 with me. We're going to multiply that by the 3%, and we're going to multiply that by what? Now, is that how most bank accounts work? No, because most bank accounts, you do make interest on your interest, which we'll be using that other formula up there for. Are you following me? Is that something that you need to pay attention to when you're looking at your wording of your bank accounts? Not for this one. This one is just going to be the word, like it's just... That's not like an actual formula. It's just going to be your, how much you invest will always be there, so that's a constant. So that would be like P for principal. And then this would be plus your principal times rate times time. Okay. That would be how much, this would be how much money he earns for 5 years. It's going to be the same amount that he earns every, it's going to stay the same. It's not going to go up. He's going to earn, let's say he earns $10 the first year. How much is he going to earn the next year? $10. How much next year? $10. $10. So it would literally go like this. He has $750 the first year. He would have $760, $770, $780. It wouldn't be changing. That $10 would be the same because he's only going to be getting interest on the $750. What happens normally? Normally you have like $750, right? Plus that $750. So this is a totally different problem. Let's pretend that his interest is allowed to gain interest. Then what would happen is you would do 750 times that 0.03, and that would get you after year one. So we'll call that year one. With me? How would we figure out the next year? We would take now, instead of the 750 here, it would be what he had in this bank account after year one. We would add the year one times the 0.03, and that would get us year two. And then here would be year two plus the dot. Does that make sense? And that's where they came up with that other formula. Okay? And there's even another formula on interest that we might get into, but probably not. We'll probably be using that guy. Good so far? Makes sense. Yes. Then this one? This? Yes, this formula. Say what? Oh, and in. How much that represents how much time. Number of cycles, I guess, is what it really means. All right. All right, we're gonna go through these pretty quick. A new car loses an average of $1,800 per year. When Nay bought her car, I guess she paid $25,000. The expression 25,000 minus 1,800 Y represents the current value of her car, where Y represents the number of years since she bought her car. What effect, if any, does the change in number of years since she bought the car have on the original price of the car? So the question is, how many years it's been, does this Y have anything to do, does it change this here? Like, if it's been 10 years since she bought her car, does it change how much she bought her car for? No. Does it change how much the car is worth? Yes, but that's not what the question is. The question is, if it's been 10 years, does that affect her initial how much she bought the car for? Why? What is that 25,000? It's a constant. That's all they're trying to get you to understand. What affects what? Now, does how many years affect how much the car's worth? Yes. Does the number of years? Yeah, that's the same thing. All right. Oh, dude, it's awesome. Hold on. This is way too clear. I'm sorry, sir. What would you like? Sounds like it, doesn't it? It's a little louder than I anticipated. Good morning. Dang, this thing got loud. I'm proud of this little mic. I'm not even mad.
How much was it?
This $30. Amazon. I get everything from Amazon. No, but I got my points from my credit card. I got 30 points going on my next cruise. I checked last night on my other credit card. Because, see, I'm telling you, if you're smart, you have to be careful. It's a game. You have to balance it. Like, you open up credit cards and you spend $3,000, they'll give you 50,000 bonus points. So, like, I have one for Delta. And I just looked at it last night, and I have 67,000 points on it. So I was just interested in looking, and because I've never been to New York, and we were, yeah. Yeah, I looked at it, and it was like 40,000 points for my wife and I to fly to New York, and that was sometime in December, because I've never been, and I thought if I was going to go, it'd be pretty cool. Huh? You can use it for, like, I have bought, like mine, there's different ones. One's miles, one's points, for the most part. Points you can use for, like, gift cards. And so we used our points for $100, or $100? Yeah, they were $100 gift cards to Royal Caribbean. And so I bought a whole bunch of those and sent them all into Royal Caribbean to pay for our cruise. Yeah, that was fun. I'll take 50. To what? No, normally 100, like $100 would be 10,000. But again, I'm spending. Yeah, it's not. Yeah, and sometimes they have like some of the cards, gas. They'll give you 3 times the amount of. So if you spend $50, they'll give you 150 points. So some things they have multipliers on. It's a game that they play. But I don't care. I'll play your game. I'm going to use the money anyways. Give me free stuff. Sounds great. But again, you have to be smart because the thing that I told you, they just need one person who's irresponsible to pay for many of me. Or her mom. All right, so money is deposited into a bank account that earns interest on the initial amount deposited as well as any interest. So this time, the money grows on the money. So when you get interest, your interest is allowed to make money. That's how most things that you, if you're going to invest, that's where you invest. You want my investment, when I get money back, I want that money now to make more money. Does that make sense? So this compound interest can be described as the expression right here. Principal times the quantity, that's how you say parentheses, by the way, 1 plus R, or rate, close those parentheses, and then to the nth power. All right, so P represents initial amount. Normally P represents principal. R represents the interest rate, and N represents the number of years that have passed. Now, there are some interest rates that you have to count that it's not going to be the number of years that pass, because sometimes it's your interest is like a credit card. When they go to get my interest, is it yearly that they do that interest? Nope. It's every, what did I say? Every month for my credit card. Did you pay this January? Oh, okay, we're going to take all that money. We're going to put interest on that. Okay, and from what I believe, that interest, they can, now you owe this much, they can take the 15% of that. I'll have to look at that. That's interesting. I think your interest, they take, and you owe them now 15% on the, like their interest gains interest. I don't think it's on your, I'll have to look at it, because I don't know. I've never been late. I don't pay anything. All right. So, how does a change in the variable affect the value of the expression? So we're going to go through and look at some of this stuff. All right, so we have this expression. All right, so what happens if I change the value of P? Do you guys see where, remember where P is? Keep this in mind. Okay, keep that in mind. What happens if I change P? Like, let's say I put $500 and everything else stays the same. And then in one bank account, I put $1,000 into it. Are you following me? So I put $500 into one bank account. It has the same rate, and I leave it in there for the same number of years. As I do one where I put $1,000 in here, same rate, same number of time, what would happen? What's going to be the difference between the two bank accounts at the end of those years? Remember, how much did I put in the first one? How much did I put in the second one? Compared, this is double, right? So guess how much is going to be in my second bank account? Twice as much. So at the end of it, if I had, $6,000 in here, I would have $12,000. Okay? But notice where the P is. It's right here. We're really looking at order of operations and how changing the numbers would affect my outcome. Now, what would happen if it says determine what the changing of R would? So changing R, now, here's the problem. Are you guys, is this kind of making sense if I do it like this? What happens if I put the same amount? So I put $500 into a bank account. I'm going to put $500 into another bank account. But this time, I'm going to put one in that only has 5%, and the other one has a 10% rate. Now, how is that going to change? It's going to be a drastic change, or is it going to be like that one? Doubling your money, is that really a giraffe, like a big change? No, not really. That's not like huge. Are you following me? So determine what effect, if any, r has. So by changing r, the base of the exponent changes. So let me ask you this. Does this change? Is there a big difference in these two answers? Oh yeah. Because here, what am I doing? I'm multiplying 2 by itself 5 times. Right? Even if we only did, here, we can even do it smaller than that. We can, just because it'll make it easier for us. What if we just did this? How far apart? And that's not that big a difference, right? I'm just 2 to the third, and now only at 3 to the third. Watch how far apart these numbers are. Because when I change that base, I'm changing what I'm multiplying by. Are you following me? So 2 times 2 is 4 times 2 is 8. 3 times 3 is, that's already bigger than that. Times another 3 is what? Are these guys really even close? So if I change my rate, is that going to have a bigger difference on, or possibly could have a bigger difference? Yeah, because I'm changing how much I'm going to be raising. Now, what else? The last thing that we can change is the number of years. Does that have a big effect? How much will it change? So if I had 4 to the second, 4 versus 4 to the third, does it have a pretty big change? Yeah, it's going to actually multiply by, go up by however many, that is. It's going to increase by that much. You guys following with what I'm talking about here? Okay. So that's all the stuff that they wanted in here. We got a couple more to go through. Stay with me. I get till 45. All right. This one right here. Is the expression 5 plus 3x always equal to 4x? This is it wasn't even really talked about. Okay? But here's what has to happen. Do you remember when you're in algebra? Well, calls it algebra. I make fun of him. So if you were back in algebra 1, do you remember when you had something like this? Something like that. You would get the x by itself, and you would get x equals 7. Something like that, right? When does the left side equal the right side? When does this equal 60? Only when x is what? Do you guys understand what you solved? This right here only equals 60 if x is what? 7. If I put a 6 in there, does this equal 60? So does this always equal 60? No, it only equals 60 when this is 7. Now that's not true, by the way. That's wrong. What you want to make it? Let's make it correct. 5 times 7 is 35, yes? Plus another 7 is what? Good? This equation only works when this is 7. Now, are there some times that the left side always equaled the right side? Yes. If you got a problem and you finished it and it said x equal to x, that meant it didn't matter what you put in for x, the left side always equaled the right side. An example of that would be something, and I'm just doing a quick one, like 4x plus 6 equals 2 times 2x plus 3. What you would do is you'd go through this problem, you would say, hey, I'm going to divide by 2, and this becomes 2x plus 6, or 3, sorry, equals 2x plus 3, minus 3, minus 3. Are you following me? 2x equals 2x, divide by 2, x equals x. What does that mean? It means no matter what you put in up here, this will always equal this side. Are you following me? So if they ask you this question, they say, does 5 plus 3x over 2, does it always equal 4x? If you get some answer like this, does this always equal this? No. What are you looking for? You're looking for what? X equaling x. So we would times by 2, cancel out, times by 2, and you get 5 plus 3x equals 4x, right? No, 8x. Sorry, if I times by 2, I times by 2 over here. With me? I would then minus 3x, so we get 5 equals 5x, divide by 5, x equals 1. Does this always equal this? Yes or no? No. When does this equal this? Only when x is what? Every other number would make that statement false. It's asking, does it always equal it? And if it always equaled it, it wouldn't matter what x you put in there, the left side would be equal to the right. That would have to happen. Are you guys understanding what I just said? That's going to be probably on the test. I'll give you something like that. Do these guys always equal each other? You'll have to tell me yes or no, and should know why. If you have x equals 1, can this equal this? Yes, if you put a 1 in for x. If you put anything else, it will not work. So does it always equal each other? No. You with me? Yes. No, I just showed you. So I could put a 5 in here, and if I put a 5 in there, this side would simplify the same numbers out. It would basically what would have to happen is this is the same as this. They are the same thing. Exactly the same thing.